Hi everyone, today we're gonna work in a problem of binomial, and here we have the problem that it's with our x, the random variable of the number of cars sold with a convertible top for the next 4 cars sold. These 4 cars sold will be our n, and this will be our probability, that is 70%. We also were gonna learn how to use the binomial table. But first we're gonna work on this problem. So here we have the values for little f for 0, 1, 2, 3, and 4 that we can calculate them here with our probabilities. So for little f of 0, we will just have one probability if we will do like a tree diagram. And so we have to multiply this for the probability of getting a sold car with not convertible. So since we have 4 cars, we have to multiply 0.3, that is the probability of not convertible, 4 times, and we will get little f. The same we will do with little f of 1, that we will have the possibilities of getting 1 out of those 4 solds, and we will multiply this time times 0.7, because there is one probability that one car is sold. So this will be 0.7 times 0.3 times 0.3 times 0.3 times the probabilities of getting one car sold out of those 4, and that will give us our little f of 1, that is 0.0756. The same we will do for little f of 2. We have here 6 possibilities that we can sold 2 cars out of those 4 with the convertible top, and we will have to multiply 6 times 0.7 and 0.7, because this 0.7 is the probability that is sold with a convertible, and that will give us 0.2646, sorry. Then for the little f of 3, we will have the same. We just have, in this case, 4 chances, and we will multiply 4 times 0.7, 0.7, 0.7, and 0.3, because this time we want to find 3. So that's why we multiply times 7 3 times. That will give us 0.4116. And for the last one, little f of 4 will be just 1 chance, same as 0. So it will be 1 times 0.7, 0.7, 0.7, and 0.7. And that will give us 0.2401. Now we're gonna try to find that at least there is one convertible. So we will take p, probability of x is equal or bigger than 1. So this will be 1 minus the probability of x is equal to 0, because as we see here, we have 1 minus p is the probability of failure. So we take our binomial, 1 minus our binomial, that this will be 0, because it's our x. This will be our n, that is 4, and this is the probability. So we operate this, where this will be the formula. And getting this formula, we will calculate this using this formula. And giving this, we will see that 4 factorial, 0 factorial, and 4 factorial, this will give us 1 times the probability of sold with convertible to our x times the probability of failure to n minus x. In this case, our x is 0, so this will be our n, and this will give us 0.081. But we are not done here, because now we have to subtract 1 minus 0.0081 to see what is the probability of at least one convertible. And here we subtract 1 minus 0.0081, and that will give us 0.9919. Then we'll go here to see the probability of exact one convertible. So since we calculate this and this before, we will have to use this formula. We will know that this is 24, and we will have to multiply the probability of at least one convertible. This should be 3, sorry. So the probability of at least one convertible to 3 times the probability of failure and this will give us 0.4116. So this. And now in the binomial table we can see that our n is 4 and our probability is 0.70. So we will have here our big F's, and if you see here, our big F of 4 is 1.0, our big F of 3 is 0.7599, our big F of 2 is 0.3483, our big F of 1 is 0.0837, and our big F of 0, it will be 0081. So how we use this table? So if we want to find the big F of 3, for example, we will just have to subtract big F of 4 minus big F of 3, and this will give us 1.0 minus 0.7599. That if we calculate this, that will be .2401. that this is little f of 4. If we want to calculate little f of 3, we will take big F of 3 minus big F of 2, and that will be 0.4116. That is f, little f of 3. If we want to calculate in this case little f of, for little f of 2, we'll take big F of 2 minus big F of 1, and having this, we'll see that 0.3483 minus 0.0837, and that will give us 0.2646. And this is how you read the table of binomials. Thank you very much.